But why it's useful to do all of these steps to identify the correlation and find the highest correlated feature with the target variable? Why it's useful? It can help us when doing the feature selection. By the sorting, the correlation values help us to identify which features have the strongest relationships with the target. This can help in selecting the most relevant features by building your machine learning model. Also, it could provide us like insight to the relationships. It provides insight into how the different features like the age, the maximum heart rate, and the old peak, and the chest pain are related to the presence or absence of the heart disease, which can inform both feature engineering and model interpretation. Next, let's take some of the simple codes just to have an overview about our data set. We'll use data from that info, and that will display the summary of the data frame, including also the null variable, that the null values that we have. Also, it could present us the data types. So let's run this code and see what would be the output. Okay. So as you could see that data or data frame.info has returned to us the number of rows in the data frame, also the columns in the data frame, the number of null entries in the data frame. So why do we use it? We use it to identify in case if we have any missing values, as well as to understand what data types that we are working with. For example, you have the age and the chest pain, the gender. Most of these are an integer. However, for the old peak, it comes as a float data type. And you could see here that we have total of 303 entries, none null. So I don't think so that we have any null values in our data set. So this is how you can get like a quick summary about your data frame. Next, we are gonna discuss how we are going to find some do some analysis for the target variable to understand the distribution of the values, and we'll do some uh, visualization to understand how our data is distributed within the data frame. So now let's find some information about the target variable that we have. Our target variable represent the patient who has a heart disease and the patient who has no heart disease. So how do we do that? We'll first define the DF, which is our data frame. We'll set that to the target, and we'll also use this method called value counts, and that will help us to turn the count of the unique value on the target of the data frame. Let's run this code now. Okay, so as you could see that we have 1 means a patient has a heart disease, and 0 means that the patient has no heart disease, with a total of 303 patients. So we have around 165 patient who has a heart disease, and 138 has no heart disease. So the value count is a method that returns a series of containing the counts of unique value in the target column. It's particularly useful for checking the distribution of the categorical variables like your target variable, in our case, whether a patient has a heart disease. Uh, so as we say that this method will help us to find how many patients have a heart disease as represented in 1, and how many patient has no heart disease, which is represented by 0. Let's now try to find more about the data, about the distribution of the target variable, to see the relative frequency of each class. We'll use this function to help us understand the distribution of the target variable, which is important for evaluating class imbalances and make decision about potential resampling techniques if needed. So let's start typing the code. Start by df with data frame, our case, okay. Value counts. Let's use this normalize equal to true. Let's run this code now. Okay, as you could see that it has returned like a percentage or the proportion of the patient who has a heart disease, which comes around for 54% out of the total data set, and remaining 45% has no heart disease. So this is how we can find, let's say, the proportion of your target based on the target variable that we have set here. Let's try now to do some visualization for that. We'll start by also defining df target dot value count, leave that empty, and then dot plot kind. So this is how we define the type of plot that we're trying to visualize here. Let's set also the color. Set it to Salmon. That has to go in parentheses. Also, the other one, light blue. Let's close that. Let's now show the plot by calling this function called plot.show. Let's see what will be the results. Okay, nice. So this is how you can, visualize the results that we have got here also. So the main functions that we have utilized here is to find the value counts. So the value counts, as we say, that it will return the unique values in the target column, which will show us how many classes are there. In our case, we have 0 and 1s. 0 mean has no heart disease, and 1 mean the patient have a heart disease. We also use to plot the results. We define the kind of the visualization that we're looking for. It's the bar, and the colors we use the salmon light blue. So this visualization will help us in quickly assessing the class distribution in our dataset. If you have a class imbalance, example of one class has significantly more samples than the others, you might consider techniques like oversampling or undersampling or using like class weights when building your model.